if you put a container of water in the freezer, now measure its temperature. Presumably it came out of the cold water faucet, so cold, it might be 45 degrees or so. So there it is. You write it down, put down what time you made that measurement. Come back an hour later, measure the temperature. It might be 40 degrees. Write down the time and the temperature. All right. And you come back again. It might be 35 degrees. So what's happening is there is heat inside the water that the colder air in the refrigerator is sucking out of it. Right. So the water is losing heat to the air in the freezer. So let's keep doing this. So all this heat energy is going into the air, and then you have compressors and things that are taking the heat out of the heated air that's in the freezer itself, and it goes onto the coils in the back of the freezer. And that's why the back of every freezer is warm. That's the heat that used to be in the food you put inside the freezer. Let's go back. What was the last temperature we measured, Chuck?
40.
So 40, and then we do it again, it's 35. Then you do it again, like a half hour later, it's 32 degrees. Oh, wait a minute, and you see some ice starting to form on the top surface. Well, it's just a film, just break through it, put the thermometer in, take another measurement, half hour later. It's still 32 degrees. Okay? Take the thermometer out, leave it in another half hour, go back. There's more frozen, but there's still some water down there. Punch through, take the temperature. It's still 32 degrees. At this point, more and more is getting cold, so why don't you leave the thermometer in there? You had been dropping the temperature over a couple of hours or a couple of intervals of 30 minutes, and then the temperature stopped dropping. The freezer's still working. Yeah. It's still pulling heat out of the cup. And so eventually the entire thing freezes. You go back, look at the thermometer, it's still 32 degrees. Then take another half hour break, go back, now it's 30 degrees.
What?
Go back, now it's 25 degrees.
Okay.
Now 20 degrees, and then 15 degrees. And if you're a good red-blooded, healthy freezer, it's 10 degrees, 5 degrees. And most freezers will get you between 0 and 5 degrees.
So why the plateau?
Why the plateau? Because it takes energy to completely stop the moving molecules in liquid water. That takes energy. So while you are slowing down the moving molecules and the temperature is dropping, because the temperature is the average speed with which the molecules are vibrating, the average kinetic energy of the molecule. So as that happens, the molecules get to a point where they can't vibrate any slower without becoming solid. And so all that extra energy getting taken out of the water is serving to create the ice. When the ice is frozen, we have solid water, and those molecules have vibrations too, but now they're vibrating in a solid lattice.